Okay, it is now to think about 4 reservations and the probability of 2 cancellations. Okay, pretty interesting. Um, First, once there must be different possible outcomes that have 2 cancellations, but anyhow, each outcome will have this much probability because 2 out of 4 reservations, there are 2 cancellations, and the other 2 are not canceled. So 0.1, 10% should be multiplied twice, and 90% should be multiplied twice. So each outcome, if you know who canceled and who didn't, then its probability should be 0.81%, right? Right. So as I said again, just cancellation happened twice, non-cancellation happened twice. So if you know just who canceled and who didn't, it's 0.81%. Now what remains is to count how many different combinations are possible for 2 cancellations, right? And then that multiplied by this probability is the answer, right? Remember this principle. We just calculated this part, which was pretty easy. Now we have to calculate this part, how many different outcomes there are in this event. And then do the brute force. There are 16 different combinations, possible outcomes, because 2 by 2 by 2 by 2, there are 4 reservations. And none is canceled, 1 canceled, and 2, A, B, A, C, A, D, B, C, B, D, C, D. These are the 2 cancellations outcomes, and 3 cancellations and 4 cancellations. Then the result is 6. That's the weird number, right? So where did 6 come from? Like we had 4 reservations, 2 cancellations. How do we get 6? That is something we have to think about in the following slides. Anyhow, in the end, if you just calculate this number, you are going to get 4.86%, right? So the answer is 4.86. Okay, I hope you get it right. Then anyhow, now our focus is on the first part. How can we count? Is there any rule counting the number of scenarios, combinations? Yes, there is. But I tried to explain its intuition, but I kind of gave up. It takes too much time. So just let me just like explain what it is, but I am not confident if I can explain why it should be like this. Okay, let me start from a new mathematical notation, factorial. N factorial is just multiplication of consecutive numbers from n down to 1. So natural number n, if you have non-negative integer n, then n exclamation mark is multiplication from n down to 1. Just multiply all the numbers, okay? And then we need this notation to define this. So think about this. A total out of n, what is the number of possible combinations when you choose n? Like y, excuse me. So we know out of n there are y cancellations. It's like how you combine the y cancellations. That is denoted as combination of n y, right? Out of n, choose y, different guys. So we read it as n choose y, n chooses y, right? Different textbooks and different papers use different notations, but on the Wikipedia I found that this is the official American Mathematical Association notation. So I'm following this notation. And then the combination rule is like this. Numerator has n factorial, and denominator has y factorial. Y is the number of success, and n minus y, number of failure factorial, right? That's the formula. And some special cases, when there is no success or no failure, it's simply 1. So choose when there is no failure, like no success, there is only one possible case. Everyone cancels. Or if everything is canceled, that is only one scenario. You don't need to know who canceled and who not. Just one possible case. And yeah, okay, let me explain it a little more with examples. Suppose that, like when you play cards, you get 5 cards out of 52 card deck. How many combinations is possible? Like it is exactly 50 chooses 5. You choose 5 different cards from 52 cards, then you calculate it this way. Okay, so general rule is success factorial times failure factorial, but you see, like below n, from n minus y down to 1 is cancelled out by n minus 1 factorial. So n numerator is n times n minus 1 times da 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 n, like 1, but smaller part is cancelled out by this. So in the end, you can think the formula in this way. You will have multiplication in the numerator and the denominator, and numerator starts from n, denominator starts from y, and denominator goes down to 1, and numerator go down to n minus y plus 1. Or, in other words, you multiply the same number of numbers, but the numerator starts from n and denominator starts from y. So back to our example. So 52 chooses 5, then the combination rule, according to the combination rule, numerator starts from 52, denominator starts from 5 down to 1. There are 5 numbers multiplied denominator. Then you have to multiply 5 numbers in the numerator too. So 52, 51, 50, 49, 48. So same numbers are multiplied in both denominator and numerator. So that's the rule. Another example. At a pizza place, there are 10 possible toppings, and you can choose up to 2 topping pizza. How many combinations can you think of? 10 chooses 2. And simpler, you are going to multiply 2 numbers, but the numerator starts from 10, denominator starts from 2. So this is the total possible pizza, 2 topping pizzas when there are 10 possible toppings. Okay, then just extend the same algebra. How can you count 5 chooses 3? Out of 5 reservations, 3 are cancelled. You choose 3 and they cancelled. How can you count the possible combinations? Try this. Okay, let me show you the answer. So the idea is, it is 5 choose 3, so you have to multiply 3 numbers in the denominator and the numerator. And numerator starts from 5 times 4 times 3, and denominator is 3 times 2 times 1, like this. That is 10. Okay? So let's check it. When there are 5 reservations, A, B, C, D, E, and I listed all the possible combinations of 3 ones and 2 zeros. ABC, ABD, ABE, ACD, ACE, blah blah blah. So this is all the possible combinations of 3 ones. So exhaustive list. So this is the number of possible combinations for 5 chooses 3. Okay, so you may apply this to any case, and of course you don't need to do it by hand. Use a calculator or Excel, then you should be able to calculate this easily. Okay, and then you get the full formula. The second part was easier. Success probability multiplied by the number of success, and failure probability multiplied to the number of failures, right? And then you have to think about different possible combinations that follows from the combination rule. Out of n, you know y cancellations. How many different combinations possible? That is this one, right? So this is the probability for a binomial random variable with parameter n and p, right? So we have this number of possible outcomes in this event and number of probability of single outcome in the event. Okay, by the way, I should have shown this to you. Let me show you how to use Excel to calculate the combination rule, right? Formulas, insert function. Combination rule is combine, right? So search. There is COMBIN, combine, combination rule. Choose this function. Then you have to enter two numbers. Out of, like say, 52, let's choose 5 cards. Out of 52 cards, I will choose 5 cards. Then, how many possible cases? This many. What is this? 2.5 million, nearly 2.6 million different scenarios when you choose 5 out of 52. And like combination of, say, 10 chooses 2. If you choose 2 toppings out of 10, there are 45 different pizza combinations for 2 topping pizzas. And similarly, like 5 choose 3. Then, as you just saw, it's 10, right? And also, you may use factorial directly. There should be factorial. It is just fact, like factorial 10. So, for example, is a huge number, and you divide it by factorial 2 and factorial 8. If you use the formula, original formula based on factorial, so 10 factorial divided by 2 factorial times 8 factorial, then you get 45, which is same thing like this. So I just showed you this either based on this, like this combination rule, or based on this factorial formula. Anyhow, so the rule is pretty weird. It's hard to explain why we get factorials here. That takes too much time. Maybe it will take another hour. So I will skip that. Just use Excel. And this is the final formula. And as I said, there are only 3 numbers, n, p, and lowercase y. Only 3 numbers can explain any probability. So the lowercase y can be any number. It is your choice, right? If you're interested in the case where there is only 1 cancellation, then lowercase y should be 1. If you're interested in the probability of 2 cancellations, then lowercase y can be 2. So by changing different y, still you can calculate the probability with those parameters, the same parameters. So that's the power of this binomial distribution model. Okay. So now then we can now explain why the previous question is now 19.37%. Our intermediate goal. There are 10 reservations, 10% cancellation probability. And what is the probability of 2 cancellations? Okay, so now, let me do it on Excel, right? So first I will calculate 10 choose out of 10 reservation. There are 2 cancellations. Then how do we, okay, it would be better to have, bigger font. It is 10 choose 2. This is how we calculate. And success probability happens, say, 0.1 to the exponent of 2, right? And failure happens, failure probability is 90%, but out of 10 reservations, only 2 are canceled, so there are 8 non-canceled tickets. So you have to calculate 0.9 to the exponent of 8. failure probability to the exponent of the number of failures, like this. And final probability, binomial probability is, typo, binomial probability is multiplication of all these. Like it's 19.37%, like this. Okay, so binomial probability is calculated this way. And of course, you don't need to do it every time when you calculate binomial, right? So I suggest go to this binom function formula. So the function is binom dot dist. Excuse me, let me do it here in another cell. So then you have to enter 4 different probabilities. First, number of success, the parameters I mean. The number of success is we are interested in 2. And trials, out of 10 reservations, we have 10 experiments. Probability of success is 10%, probability of cancellations. So these two, 10 and 0.1 are parameters, and 2 is just the number we are interested in. And cumulative, no, false. You have to enter either false or true here. We learned cumulative probability in the previous chapter, but now we are not interested in cumulative. So I say false, then okay. You get the same number, right? So same probability here. So you may use the original formula or this binom.dist formula. So this formula will do the will implement this formula. Okay, so you get the result. Anyhow, again, if you understand how this formula is derived, algebra is not a big problem. Like you can use Excel. So just what you need to do is to understand the basic idea. Especially, I want to emphasize this. There are 2 common mistakes. First, people ignore failures. Like usually we say what is the probability of 2 cancellations. Then you have to think about the other 8 are not canceled, right? So the other 8 are doing something in the background. You have to calculate their probability too. And second, it is not a single outcome, right? You have to think about different combinations. If there are 2 cancellations, you have to think about who canceled and who not. So that is kind of annoying part of this probability calculation. Okay, so I hope these 2 videos explain how we got the probability distribution, the formula. So in the end, summarize in sum, if y, random variable y, follows a binomial distribution with parameter n and p, that means y, the random variable can take n plus 1 different values, different outcomes between 0 and n. And for all these n plus 1 different values, they follow the same formula like this. So you can change lowercase y from 0 to n, but the formula is the same. So as you can see, 2 parameters explain n plus 1 probabilities. So it's a huge savings, right? Saving of work and time and paper, You do not lose any information. And of course, it has to satisfy the previous assumptions that I discussed at the beginning. And if you make a histogram based on these parameters, say I try 20 questions with probability 10%. So if you try 20 experiments with 10% success, the distribution of success will be on the lower side because it's less likely to happen, success less likely to happen. But as the probability of success increases, distribution will move to the larger side, like here, it's centered around 10. It's centered around like 18. It's centered around 2, right? Which is natural as the shape changes as P changes. Now, if you change the number of trials when n is 5 and like the range is from 0 to 5, but as n increases, it changes to 0 to 10, 0 to 20. So the n is about the range, and of course, like it's distributed across more values, so the height should be lower because probability goes to more different values. Okay, and I will skip complicated algebra. As I said, with these two parameters, we can explain everything. And if you do tedious algebra, you can calculate the mean and the variance using the probability formula. That is, in the end, pretty simple. The expectation of a binomial random variable is n times p. So if you try n times and you succeed p probability, so if you multiply them, that is the expected number of success, right? So if you try more, or if the probability of success is higher, you are going to get better expected number of success. But the variance is n times success probability times failure probability. The later part is same as binary distribution, same intuition hold, right? So if P is close to 50%, it's unpredictable. But if P is close to 0 or 1, the predictability is predictability increases, so variance will be close to 0. But as n increases, the range increases, as you saw in the previous page. So as the number of trials increase, the range increases, so it's spread out more. So the variability increases, variance increases proportionally. Okay, right? Anyhow, it is pretty simple formula. So whenever you need them, you can just pick like this slide. Okay, should be simple enough. And now I will leave it to your question. Pretty simple because I gave you the parameters. So you should just apply the previous formulas, calculate the mean and variance. Okay. Okay, then I will finish this video now. In the next video, I will use another example and I'll explain something difficult, like more different, like cumulative probability distribution. Okay, see you there. Bye.